Hey there, Art22. Today we're going to be looking at how to get our processing environment up and running. So we're going to download processing together, we're going to explore the interface, and we're even going to write a little bit of code together today just to get ourselves a little bit used to this new ecosystem that we're working in. Now, processing is a computer programming language that is geared towards creating visual content and towards creative coding practices. There's a lot of things built into processing that make it easy to do these more creative ideas, and we're going to see a lot of them. There's many other programming languages out there, and maybe you even know some of them or will eventually learn some of them. But we're going to be sticking with processing because it's a great place to get started, especially if you've never programmed before. It's actually the first language I learned how to write code in, and I think it's a great place for a lot of people to start, even if you end up doing it coding for more technical reasons or not necessarily for creative coding. It's the same concepts of computer science that run throughout all programming. And so we're going to be downloading that today and getting that up and running. So why don't we go ahead and jump into it. Okay, so here we are. We've landed on the processing homepage, processing.org, so head that way. And there's a lot going on here, actually. Processing does a lot of great work with their processing foundation. They have some cool exhibition pages that highlight some projects that have been made in processing. There are ways to donate to the project because it's all open source, so any support is always helpful. Tutorials, examples, books, all that good stuff. But what we need to do first is actually download processing. And so we can do that by coming over here to download. And now you basically just have to select whichever platform you are on. I'm on a Mac, but you might be on Windows or Linux. When you click this, it'll start downloading. And it'll also probably prompt a page where you're able to donate. Obviously no pressure, certainly can if you like. But once you get processing downloaded, you should see this icon here, this big kind of P3 looking thing, show up probably on your desktop. Once it does, go ahead and drag that into wherever you want it to live on your computer. For me, I dragged it into my applications folder. So here I have processing in my applications folder. You'll note that I have processing 2. This was the old version of processing. We're now on 3. I'm not going to get into the reasons why I still have the old one around. There are a few, but we don't need to worry about that for our class. So once this thing is downloaded, we can go ahead and double click. Okay. Aha, popped up on my other screen. Okay. So here is the processing IDE, is what they call it, the Integrated Development Environment. Basically that means this is our environment that we're going to be writing all of our code in. The reason for that name, Integrated Development Environment, is this window, basically, this application processing, lets us write all of our code in here in this main menu, and then actually run it and then display whatever we've made. Other languages get a bit more technical in how you have to set this up, but processing makes it pretty darn easy for us to get that up and running without really having to do much of anything. First things first, every time I open up a new processing sketch, that's what they call them, by the way, or a sketch, I like to go ahead and right away just save it. So if you go to File, Save, or you can see Command S, it's going to prompt you to save this somewhere. And so I'm going to go ahead and just put it in my teaching. I'm just going to call it, it usually helps to make it something that is meaningful when you look at it later and you forgot what the heck you were doing. So in this case, maybe I'll say Week 1, Class 1. I'll go ahead and hit save, and there we go. Now, one other little tip that's kind of helpful, if you ever need to find where your sketch is saved, like you kind of lost track of it a little bit, you can actually go to sketch, show sketch folder, or Command K. And what that's going to do is actually bring up the location of where your sketch is saved. So let's take a look at the anatomy of what was actually saved. So you can see that processing created a folder for us called Week1 Class1. And inside of that, we have a file called Week1 Class1.pde. So the .pde part is the extension for processing files. And by default, it made a folder of the same name that contains this file. Now this is very important. The way processing works is you're always going to need to have your sketch, this .pde file, living inside of a folder that has the same name. So just something to kind of keep track of. Okay, so now we have our environment set up. We have a little bit of an understanding of where we're going to be writing code, where we're going to be saving it. Let's talk for a little bit about how we're going to organize our code and how we're going to actually write it. Okay, so I like to think about coding, especially at the beginning, as a bit of a metaphor to cooking and recipes. Okay, so let's say you have your recipe book, whatever, not sponsored in any way. But when you look at a recipe, you're going to find that there are kind of three general components to it. You're going to have a list of ingredients. You're going to have some indication of how those ingredients should be initially prepared. And then you're going to have a whole list of instructions of what to do with those ingredients. So for example, maybe you have an ingredient of an onion. And maybe you have an instruction that initially this onion should be diced. And then during the actual instructions of the recipe, you might have a whole bunch of things you're doing to that onion. Maybe you're sauteing it first, and then maybe you're combining it with other ingredients later. Maybe you're frying it, could do a whole bunch of things. But that's the way I like to think about recipes and code, is that you have a list of things you're going to use. You have an initial condition or initial state of how these are prepared, like a diced onion. And then you have a series of instructions of what you're going to be doing with those ingredients. And so that's how I want us to start thinking about preparing our code, because we're going to have three sections, just like the recipe. We're going to have a section at the top of our code where we're going to say, here's all the things we're going to need to use in our code. And we can always add more to that later, but we'll see that we can get a few things up there initially. Then we're going to have a middle section called setup, and that's where we're going to prepare whatever initial state we want our ingredients to be. And finally, we're going to have this section of our code called draw, and that's where all the things we do to those ingredients is going to happen. That's kind of where all the action happens. So why don't we do this? Let's jump in and make an initial code together, and we'll see how this recipe metaphor kind of makes sense inside creative coding world. All right, so let's jump into that. Okay, so here we are in our code. I mentioned there's going to be three sections to our code: the kind of ingredient list, the preparation section, and then where all the action happens. So let's get that kind of set up. And the nice thing for us is that this will be the same for almost every single processing sketch we make. There'll be some variation, but this will be how we start almost every single sketch and every single piece of code that we do in this class. So what I'm going to do is put in the two sections of code that will always be here. So I'm going to leave a little space. This is going to be where our ingredients will be. Ingredients. Now you see that I put two dashes here. I'm sorry, two slashes here. So what that does is it basically tells processing that whatever we write on that same line, ignore it. It's not part of our code. It's just a comment that we write to help make the code more readable. So put two of those and then wrote ingredients. So we're going to have an ingredient section here. We'll actually come back to that in a second. Now, let's have a section called, how about set up the ingredients? And then finally, cook. Okay. So let's actually start writing some of the code that's going to make all this happen. We'll come back to the ingredient list, but processing has us do this with every sketch to get things up and running. So we're going to say void setup, 2 parentheses, and then we need these little curly bracket things. So one kind of open and one closed. So what we've done here is we've created a section of our code called setup. And this is where we can initialize and kind of prepare whatever ingredients that we have up here. And to give you a more concrete example, since we're coding for the arts, we're probably going to want to see stuff. So the first thing we're going to need to do is tell processing that we want a window where we can draw a bunch of stuff to it. So to do that, it's actually as easy as just saying size. And then let's say about 600 by 600. And so what that means is I want processing to give me a window of 600 by 600. Now what is 600 by 600? That is the number of pixels for the dimensions of our window. So we just made, or we will when we run this, we'll have a window where things can be drawn that is 600 pixels by 600 pixels, so a nice square. Let's just see what happens if we do that. So I'm going to go up here to this play button and hit run. Okay, jump to my other screen, but let's bring it back in here. And there we go. So now we have made a window of 600 pixels by 600 pixels. Okay, cool. Not very exciting, but at least we got some stuff happening. Now let's take note of a couple things I did. First thing is you'll see I added this semicolon at the end of the line of code. Most of the lines of code that we're going to write will have a semicolon at the end. It's basically a way of us telling processing that we are at the end of this command. You can move on to the next thing. Okay. Alrighty. So now we have a window. We've got a setup section of our code. We'll put some more stuff in here later. The other section of our code where all the action happens, let's maybe make this slightly more descriptive. How about do actions with the ingredients? Okay, so this section of code is going to be called draw. There we go. So you can see it's set up the same way as setup. We always say void. We have these parentheses, 2 curly brackets. Just this time I changed the name to draw. We'll see later that we can make our own sections of code. These are like functions. But every processing sketch that we do is going to have draw and setup. And processing behind the scenes knows about setup and draw and knows that knows to expect it, which is good for us. Okay. So let's get an ingredient here and start to see what this whole silly cooking metaphor I was talking about is all about. So wouldn't make sense so much to have food ingredients in our code, although that could be interesting. We're going to be working more with things that computers expect to see. So namely, we're going to be dealing with numbers, letters, geometries, images, movies, shapes, all these things. We're going to get into all of it. But for now, let's keep it pretty simple. Let's just deal with the number for the moment. So when we make add a new ingredient to our code, it's called a variable. And so variables need names. So for example, let's say I wanted to have a variable called number. There's our semicolon. I need to tell processing what type of thing this variable is. And so we do that by, before the name of it, saying its type. So in this case, I'm going to write int, And you see that it turned orange. That is a good thing. That usually means that processing understands what we're doing and it automatically formats our text to reflect that we've given it a valid type. So what does int stand for? Int stands for integer. So basically, if we make a new variable, we can call it anything we want. We could have called this that. It'd still be okay. But usually it's a good practice to make your variables something that makes a bit more sense. It's a number. So what we've just told processing to do is create a new variable named number, and its type is an integer, so a whole number. This would be sort of like, all of us in this class are humans, but I happen to be named Mark. So you can imagine if there was a type called human, maybe that would turn orange, and then Mark would be the name of that particular human. It's the same thing with this. Integers exist, whole numbers, and we're going to name this particular one number. We'll come back and see that there's other types of numbers we can work with, but let's just stick with this for a second. Okay, so we have our first ingredient. It's a number. Let's go ahead and in our setup section, prepare that first ingredient. So maybe at the beginning, we want our number to be equal to 4. Cool. So now we've introduced our ingredient. We've kind of prepared it. Now we need to do something with it. Or you don't have to, but it's definitely more exciting if something happens. So one of the first things that is a good idea to do when you're kind of new to a new programming environment or new to programming in general is to figure out how you can get the software to talk back to you. And what I mean by that is there's going to be times where we need to know what's kind of happening in our code. And the way we can do that is by printing things to the console. So you'll see that in this bottom section of our IDE, we have this black area, and it's called console. So what we can do is we can tell processing to print information to, and that will pop up down here in the console. So for example, what I'm going to say is print ln, I'll get back to that in a minute. And what do I want to print? I want it to print our number. You can see I put another semicolon. Let's see what happens when I run this. Magic. Okay, we have a 4. So, and you're probably seeing your window pop up right in front of you. I have another monitor, so it keeps moving over to that side. So nothing's happened here. That's to be expected. We didn't tell it to draw anything yet, but we did tell it to print our variable called number. And it did. What is number equal to? It's equal to 4, so it printed 4. Now, what is that little ln? So when we add the ln to print, it basically means after we do this print, go to a new line. We'll see why this is useful soon, but it's basically just a way to make sure that our console doesn't get super cluttered up, and that after every time we print something, we get a new line. So if we were to print, let's do this. I'm going to copy print. I'm going to print our number 3 times. Boom, boom, boom. Okay. So by virtue of saying ln, it gave me a new line every single time we printed. Definitely helps for clarity of reading. Okay, so we had an ingredient, we prepared it, and then we did something with it. That's pretty cool. Let's get rid of this for these two for a moment. Now, the biggest thing to note as a difference between the section of our code called setup and the section of our code called draw is that setup only happens exactly one time when you start running your code. So right at the beginning, when we hit run, processing says, okay, make a window that's 600 by 600, set our number variable equal to 4, and print that number. And then nothing in here happens again. That happens exactly once, and then we kind of move on. The contrast is that our draw section, this happens over and over and over and over and over and over again until we end our program. So in our cooking metaphor, this would be like, you know, we've diced our onion. Now we might say something, imagine this is a function, like stir onion. It's not a function, but as processing tells us down here, stir onion does not exist, unfortunately. But if we were to run that here, this would happen over and over and over and over again until we hit stop on our program. All right, so you may be like, all right, I don't know if I believe you, Mark. I just met you. I don't know, seems suspect. Let's prove that thought. So I'm going to get rid of the print up here, copy it, delete it. I'm going to print our number down here. And from what I just told you, that this thing runs over and over and over and over again, we should see our number being printed over and over and over again. Let's see if that is true. And there it goes. You can kind of see here down on the right that our scroll bar is going a little crazy. That's because we're doing this a whole bunch of times. So I just stopped my program, and we can see there are a lot of 4s. A whole bunch. And at some point it chops. There's even more than this, but it kind of, the history of our console only goes back so far. All right, so that proves the point that this thing is happening over and over and over again. So let's think about exactly what that means. So think about if you've ever seen someone make like a stop motion animation or like a flip book, or even if you've had any experience doing maybe video, we have something called a frame rate. And so the frame rate is basically how many, it is measured in frames per second. So basically what a frame rate tells us is how many frames of an image are we seeing per second. So imagine if we had that flip book that had like 100 pages and we flipped it through at 1 second, the frame rate would be 100 frames per second. We do it, there it is. But it gives us the illusion of motion, basically. The whole idea of motion picture is that we have a bunch of still images that when you go through them very quickly, it gives us the sort of the illusion of motion. That's what's happening in our draw section of our code. Things are happening over and over again at a frame rate, so that if we were to draw something and have it move, it's going to be updating at our frame rate. So by default, processing makes our frame rate 60 frames per second. So that means that our little draw section there is running over and over again 60 times per second. That's pretty fast, actually. We can change that number, but we rarely will need to in this class. But that's what's happening with our draw section. And so anything we put in there is going to happen 60 times per second over and over and over and over again. So just something good to be aware of. And in a minute here, we're going to see how we can actually use that to our advantage. Okay, so let's look at that. All right, so let's illustrate a bit more about this idea of having things happen over and over again in our draw section. So instead of just printing number, what I'm going to do is I'm going to increase number by 1 with every single frame that goes by. So how can we do that? Well, we can use the power of mathematics. So we'll say number equals number plus 1. Okay, so let's think about this for a second. We know that this part of our code is happening over and over again, 60 times per second. And we know that we're going to take our number and we're going to set it equal to itself plus 1. Okay, so we initially said that our number is 4. So that should be 4. 4 equals 4 plus 1. So when we print number here, that should be 5. Now we go back to the beginning of our draw section. Now number is 5. So number is going to equal 5 plus 1. So this should be 6. So what we should see is numbers ascending by 1 with every single frame of our animation here. Let's go ahead and make sure that that works like we think it does. Cool, there it goes. And this would just keep on going forever, or more likely until my computer died. And yeah, really until we stop it, which I'm going to do. But if we kind of look back here at our console, we can see, yep, everything is going up by 1. We're just printing out that number. Okay. All right, so let's do one last thing, something a bit more interesting than just numbers and printing stuff. Let's actually draw something, and maybe let's even make it move a little bit. How about that? So I'm gonna, you're gonna see this a lot in our code where I've made something that I want to ignore, but I don't want to delete it because I want you to be able to see it later. So when that's the case, what I do is, remember how we used our slashes here to make a comment? I'm going to do the same thing here. I'm going to say, ignore that, ignore that. There's a shortcut if you were to say command slash, // so I can go back and forth between comments just by hitting command slash. Okay, so now even though this code is here, processing is going to ignore it because I'm going to do some other stuff here. All right, so what I'm going to do is give you our first taste of using something called a 2D primitive. Now what does that mean? A 2D primitive is just a very basic geometry. So processing has a lot of these, rectangles, ellipses, points, lines, triangles. And we're going to use one right now just to see some stuff on our window, because we've kind of been ignoring our window. So what I'm going to do, first things first, is I want to draw a background, because if you remember we run this, we get kind of a bland gray color as our default. We can change this background very easily just by saying background. And now we have to put a color. How do we put a color? I can't just say red. That wouldn't work. So in Computerland, and by default in processing, we represent color by RGB. What does that stand for? Red, green, blue. So that's basically, we can represent almost any color as a combination of how much red, how much green, and how much blue there is. And each of those RGB has a range from 0 to 255. So here, let's illustrate a point here. I'm going to say 0, 0, 0. So 0 amount of red, 0 amount of, what is it, RG, green, 0 amount of blue. If there's 0 amount of all those, we're going to see black. And there we go. There is our black background. Now if we were to put them to the maximum number, 255, you guessed it, we're going to see white. 255, 255, 255. There we go. Now we have a white background. Very cool. All right, let's keep it on white. How about? All right, so let's draw something here. Why don't we do this? I'm going to say we want a rectangle. Now, I mentioned before that processing has a lot of built-in stuff that's really easy for us to use. These 2D primitives are a great example for that. So if I want a rectangle, all I have to say is rect, R-E-C-T, and give it 2 parentheses and a semicolon. And now processing wants some stuff from us. For a rectangle, it wants to know the location on our screen and the size of our rectangle, width and height. We're going to get into this more in the next lecture, but let's just put in a couple numbers here just to see. So let's say I wanted our rectangle to be at 100 pixels in the x direction. So think of your graphs from math class or something like that. Its x location, horizontal location, is 100 pixels in. How about we say 200 pixels down in the y direction, in the vertical direction. And now we need a width and a height. So let's say we want our rectangle to be 20 pixels wide by 20 pixels tall. Okay. Let's run that. Aha, there we go. So now we see we have this little teeny rectangle that is 100 pixels in the x direction and 200 pixels in the y direction. So you might note that as I'm tracing that with my mouse, that processing by default says that 0, 0, our origin, is actually up in this left corner. Our x direction is horizontal, so we go from 0 all the way to 600 in our current case, because our window is 600 by 600. So we go from x is 0 all the way up to 600, and then we go from y is 0 all the way down to 600. So that's kind of the counterintuitive part if you are new to programming, is that y in this case is getting bigger the further down we go, at least in our current situation. Okay, so let's make this a little more interesting. You remember that we built this number variable, and we actually had this method for increasing it. So I think what we could do is replace one of these numbers, our location, with our variable, and that means that this location will change over time, which is going to give us the illusion of movement. So let's check that out. So as of right now, I said, okay, let's give me a rectangle that's at 100 pixels across and 2 pixels down. Let's say that I actually want this rectangle to be at number pixels in the x direction. Well, that's kind of weird, right? So what does that mean? Well, we said that number is 4. So really all this is saying is start our rectangle at x equals 4, so 4 pixels into our window, and still 200 pixels down. So let's keep this part commented out and see what that gives us. Aha, okay, great. So we're still 200 pixels down in the y direction. I lost it. Come back. Okay. But now we are number pixels in the x direction. So we are 4 pixels over and 200 pixels down. Great. So now that we know that we can use variables in place of numbers, we can start to do some interesting things to it. Now if we were to bring back in this idea where we had number equals number plus 1, what we should see is this x position getting bigger over time. And so what does getting bigger mean? It means it's going from 4 to 5 to 6 to 7 to 8 to 9 to 10 all the way across. Let's see if that is true. I'm going to uncomment our number equals number plus 1. And what we should see is a moving rectangle. Except it was over on the wrong screen. And there you can see it going. So this is kind of animation for you. It's a bunch of still frames, drawing things on a frame and then cycling through those frames. In our next lecture, we're going to get much more into the shapes we can draw, colors, movement, all these things. But that's a pretty good place to get to today. So just a few more details to mention. For your code for this class, there's going to be 2 other things I'd like you to do. So I'm just going to kind of consolidate this a little bit. The first thing is comments. So comments are really helpful for when you either make code and then a lot of time has passed and you come back to it and you're like, what in the world was I doing? Or if you're sharing your code with someone else, because maybe they're also new to coding, or maybe they don't know exactly the type of thing you're doing, they might need to have some hints as to what your code is actually doing. So especially at the beginning, I'm going to ask you all to very heavily comment your code so that basically every single line is accounted for. So what does that mean? So what I'm going to do here is I'm going to say create a integer variable named number. Okay. Create a window that is 600 by 600. Set number to 4. Now this is, kind of tedious, but I wanted you to do it first just to make sure that you are, it's kind of a way to check yourself to make sure you actually know what every single line is doing. Because it can be very easy in coding to be following along and you're writing stuff, but then you're like, wait a second, you get home later and you're like, oh, I actually don't really know what that's doing. So having comments for each line is going to help ensure that you really understand what's happening in your code. So let me just do these couple last ones here. So change background color to white. Draw a rectangle. Yeah, we can leave it there for now. Maybe I'll put X, Y, width, height, just to remember what goes into that. Increase number by 1. Print number. So some of these are a little bit redundant, like print line number is pretty evident. So as we get a week or two into the course, we can probably relax some of these comments, but it's kind of a good practice to do right now. And the final thing that will be very important for your homeworks especially is to have a header. So that means at the top of your code, I want you to have, kind of like you would for a writing assignment or something, have a little bit of information about what this code is. So I might say something like, in class code, week 1, class 1, Art22, spring 2020, and then maybe the author, Mark Hirsch. And you can maybe throw the date in there, why not? But when you turn in your code, it should have a header like this. It should have plenty of comments that let me know what you're doing. And I think that is it. Next lecture, we'll get more into drawing things, some more interesting behavior and color, and we'll keep getting after it. All right, thanks everyone.